Imagine dropping $50,000 on this rare, flawlessly green gem.
Right. A really serious investment.
Exactly. You've negotiated the price, you've examined the setting, and most importantly, you have the official, highly detailed lab certificate proving the stone is authentic.
Which is usually where people stop worrying.
Yeah, you put it in a safe, or you wear it on special occasions, and you feel totally confident. But what you don't realize is that your prized stone is legally, chemically, and inevitably destined to rust from the inside out.
It's a terrifying thought for any collector.
It really is.
Yeah.
So welcome to our latest deep dive. Today we are entirely redefining a material you probably thought you understood. You sent us this fascinating stack of research that basically strips away all the mythology of jade.
And there's a lot of mythology there.
Tons of it. But by the end of this conversation, you're going to understand the microscopic chemistry of this gem, how to spot a master-level market scam, and why a seemingly perfect lab certificate might actually be the exact tool scammers use to hide a cheap imitation in plain sight.
It's a really fascinating collision of disciplines, honestly. You have millennia of cultural, almost mythological value placed on this green stone.
Right.
And now, in the modern market, that ancient value is being aggressively weaponized by exact chemical formulas and microscopic geological origins. It is this wild clash of romantic history and ruthless hard science.
Okay, let's unpack this. Because the very first massive revelation in the sources completely rewrites the basics. Scientifically speaking, the word jade doesn't actually refer to one specific stone.
No, it doesn't at all.
It's just this historical umbrella term that covers two entirely different minerals. We have jadeite, and then we have nephrite.
That is the great divide right there.
Yeah.
To understand the economics of the modern market,
Right.
you really have to look past the green color and look directly at the chemical DNA.
Which is drastically different.
Completely different. So Burmese jadeite, which is the incredibly rare, highly prized variety that breaks all the auction records, that is sodium aluminum silicate. The exact formula is NaLC-206. Now, on the other hand, nephrite, which is the material making up the vast majority of those traditional, historical Chinese jade carvings, that is magnesium calcium silicate.
Let me stop you right there. Sodium and aluminum on one side and magnesium and calcium on the other?
Yep.
That is not a slight variation or, a different shade of green. That is a completely different chemical makeup.
It's totally unrelated chemically.
It's like comparing gold to platinum. I mean, sure, they are both heavy, highly valuable, historically significant metals that we use in jewelry, but chemically, they are distinct elements. They behave completely differently in the physical world.
That's a highly accurate comparison. They were historically conflated just because they can look similar to the naked eye, but structurally they are worlds apart. And because they are chemically different, they behave differently under physical stress.
Which is how we tell them apart, right?
Exactly. That's how we do it without needing to drag a mass spectrometer to the jewelry store. The most immediate measurable difference is the Mohs hardness scale.
Right, the scratch test.
Yeah, Burmese jadeite is exceptionally tough. It sits at a 6.5 to a 7. Whereas nephrite is slightly more yielding, it sits around a 6 to a 6.5.
Which makes sense because that explains why nephrite is the traditional choice for those massive, intricately detailed carvings you see in museums.
It's perfect for carving.
Right. It's slightly softer, so it yields to the carver's tools without shattering. But how does that hardness difference actually translate to what we see when we look at a finished piece of jewelry?
Well, it dictates the luster. Because jadeite is so extremely hard, it can take a much more aggressive high-friction polish. It achieves what gemologists call a vitreous luster.
Meaning it looks glass-like.
Exactly. It looks like gleaming high-end glass. Nephrite, being slightly softer, just doesn't take that extreme polish. It has a greasy or a waxy luster.
So it looks a bit duller.
Right. It absorbs light rather than sharply reflecting it back at you.
And I guess that ties directly into how they handle light internally, right? The refractive index.
Precisely. Jadeite has a higher refractive index, usually around 1.66. Nephrite is lower, around 1.62.
Let's break down the mechanics of that for a second. If I'm holding these stones in a market, I can't exactly pull out a laser pointer and measure the refractive index.
No, probably not a good idea.
Right, so how does that number actually change the physical appearance of the stone in my hand?
Think of the internal microscopic structure as a hall of mirrors. Under a microscope, jadeite has this very granular structure. It's composed of tightly intertwined crystals or grains that basically lock together.
And the sources mention a specific term for that, right?
Yes, in the Burmese jade trade, they call this exact texture kayak thar, which literally translates to stone flesh.
Stone flesh, wow.
Yeah, it's very descriptive. When light enters jadeite, it hits those dense interlocking grains, bounces around intensely, and then shoots back out. That's what creates that brilliance.
And nephrite is different.
Very. Nephrite is made of fine, tightly woven fibers. It looks almost like a microscopic blanket. So when light enters nephrite, that fibrous structure catches and diffuses the light. You get a softer, muted glow rather than a brilliant, sharp flash.
That is super clear. And if we just close our eyes and use our hands, the physical density is the next massive giveaway. Specific gravity.
The weight of it.
Yeah. Burmese jadeite sits at a 3.3 to 3.36, while nephrite is significantly lighter, between 2.90 and 3.03. So if you hold two identically sized, identically carved pieces, one jadeite, one nephrite, the jadeite just feels noticeably heavier. It grands itself in your palm.
It really does. It's a very distinct physical sensation. Once you feel that dense gravity of true jadeite, nephrite just feels surprisingly light by comparison.
Okay, so if we are separating the true investment-grade treasures from the everyday carvings, jadeite is clearly the harder, shinier, heavier stone with that distinct granular kayak thar structure. But here's where the narrative takes a really sharp turn. Because we have Burmese jadeite, and we also have Guatemalan jadeite. And they share the exact same chemical formula, sodium aluminum silicate.
They do. Chemically, they are both unequivocally classified as jadeite.
Right.
But their geographical origin dictates a massive fundamental difference in quality, stability, and of course, value.
Wait, I really need to challenge this. If the chemical formula is completely identical, why does the geography matter at all? I mean, isn't a molecule of sodium aluminum silicate just a molecule regardless of whether it's formed under a mountain in Myanmar or near a fault line in Guatemala?
You'd think so, but it's not just about the ingredients. It's about the oven they were baked in.
The oven?
Yes, the geology. The geological pressure in Myanmar during the formation of Burmese jadeite was exponentially higher than the tectonic conditions in Guatemala.
Oh, I see.
That immense crushing pressure forces the granular structure of the stone to become unbelievably compact. It forces the specific gravity to hit that benchmark of 3.33 consistently.
So it's literally physically denser because it was crushed harder by the earth.
Precisely. In fact, that Burmese density is so extreme that the stone acts as an incredibly efficient thermal conductor.
Wait, really?
Yeah, when you touch genuine Burmese jade, it rapidly pulls heat away from your skin. That is exactly why the real stone feels distinctly cold to the touch when you pick it up.
Oh, that makes so much sense.
And Guatemalan jadeite, because it formed under less pressure, has a looser microscopic structure. It's more porous, it hovers at a lower density, around 3.2 to 3.30. It just doesn't have that signature icy density.
Okay, the density explains the physical feel, but the visual value, you know, the reason people paid millions of dollars at auction that comes from the color, and that's where the microscopic intruders come in.
Yes, the trace elements. This is literally the difference between a stone that belongs in a museum and a stone that belongs in a gravel pit.
That is a harsh distinction.
It's true, though. Burmese jadeite gets its vivid, electrifying green from chromium. Chromium atoms actually replace some of the aluminum atoms in the crystal lattice.
And how does that affect the light?
When visible light hits the stone, the chromium absorbs the yellow and blue wavelengths and powerfully reflects the green. It makes the color practically vibrate with saturation.
And Guatemalan jadeite.
Guatemalan jadeite is colored primarily by iron.
Here's where it gets really interesting. Because of the iron, Guatemalan jade takes on a darker, bluish, sometimes murky tint.
Right.
When light tries to pass through it, the iron absorbs too much of the spectrum. It makes the stone look dull or lifeless compared to that chromium-fueled fire of the Burmese jade.
It just doesn't pop the same way.
So if the Guatemalan stone is less dense, structurally looser, and noticeably duller, who is actually driving the demand for it? Why buy it?
Well, nobody is seeking it out at high prices on purpose. It's being pushed onto buyers through a highly sophisticated system of market deception.
Scams, basically.
Exactly. Guatemalan jade is technically a natural type A stone, meaning it hasn't been artificially injected with dyes or polymers, so it easily passes basic authenticity tests.
Oh, wow.
Yeah, but it is being weaponized to extract Burmese prices from uninformed buyers.
Let's walk through the exact mechanics of these scams, because the markup is staggering, often 5 to 10 times the actual value of the Guatemalan stone.
It's wild. The deception relies entirely on visual mimicking. For example, Guatemala naturally produces these deep blue-green stones. Scammers take these and label them as blue water jade.
And what is blue water jade supposed to be?
True Burmese blue water jade is a geological anomaly. It's obscenely rare and commands astronomical prices. By slapping the blue water label on a common Guatemalan stone, they manufacture rarity where there is none.
And they do the exact same thing with black jade.
Yes, and the visual trick here is so fascinating. Genuine Burmese black jadeite, which is known to the trade as moss sitsit, has a highly specific property.
The flashlight trick.
Exactly. If you press a strong, concentrated flashlight right against the edge of the stone, the light that manages to bleed through the blackness is a stunning, brilliant green.
Like a glowing ember almost.
Right. Now, Guatemalan black jade, which is often an anthracite-rich variety, also shines green under a flashlight.
But because of the high iron content we just talked about, it's a totally different kind of green. The light struggles through that heavy iron saturation, so you get this murky, heavy green glow, rather than the brilliant flash of the moss sitsit.
It's very sluggish light.
But to an untrained buyer who merely heard black jade shines green under a light, the Guatemalan stone perfectly fits the criteria. They know just enough to be completely fooled.
Exactly. And that brings us to the most brilliant and frankly infuriating part of this whole ecosystem, the lab certificate loophole.
This part blew my mind.
You would assume a gemological lab test is the ultimate defense. You send the stone to a lab, they put it through a mass spectrometer, and you get an official certificate.
Case closed, right?
You'd think. But the scammers have figured out how to weaponize the absolute scientific truth against the buyer.
It's a masterclass in the omission of data. Walk us through how a perfectly accurate lab report facilitates a scam.
So a lab receives a piece of Guatemalan jade. They run a chemical analysis, and it definitively confirms it's sodium aluminum silicate. The lab then issues a highly official, embossed document declaring the stone is jadeite.
Which is true.
It is a legally, scientifically accurate certificate.
But they leave the origin field blank.
Exactly. They intentionally do not specify Guatemala.
Unbelievable.
The scammer takes this geographically anonymous, legally accurate certificate, pairs it with a Guatemalan stone that superficially mimics a Burmese variety, and charges the buyer Burmese prices.
And the buyer looks at the paper, sees the official lab stamp, and just assumes it proves the value.
When it only proves the chemical family.
And here's where we tie the microscopic physics directly back to the buyer's wallet. Because this isn't just a matter of overpaying for a slightly less pretty stone, it's a structural time bomb. Let's talk about weathering.
This is the ultimate danger of Guatemalan jade. We established earlier that Guatemalan jadeite has a looser, more porous granular structure than the tightly packed Burmese jade, correct?
Right, because it was formed under less geological pressure, the grains just aren't crushed together as tightly.
Because of that microscopic porosity, the stone is not perfectly sealed. Over time, ambient moisture and oxygen from the air seep into those microscopic gaps between the grains.
And what happens when oxygen and moisture meet the high concentration of iron trapped inside the Guatemalan stone?
It oxidizes. It literally rusts from the inside out.
It rusts like an old car.
Precisely. The iron undergoes a slow chemical reaction, and the physical color of the stone begins to mutate. That deep green or blue will start turning a muddy brown, or the color will bleach out entirely, leaving you with a dull, lifeless rock.
It is a physical chemical certainty. You buy a piece of Guatemalan jade because it looks impressive under the high-intensity halogen lights of a jewelry showroom.
Where everything looks good.
Exactly. But the moment you take it home, the ambient air begins a slow, irreversible chemical reaction. It's like buying a luxury car with a cheap paint job that looks great in the showroom, but starts rusting the minute you drive it off the lot.
That's a perfect analogy, because Burmese jade gets its green from chromium, and it possesses that incredibly dense, impenetrable structure. It is physically immune to this oxidation.
So it holds its beauty permanently.
It really does. That is the crux of why Burmese jade is viewed as a generational appreciating asset, while Guatemalan jade is a depreciating asset, masquerading as an heirloom.
Which means knowing how to spot the difference in the real world is paramount. If you're evaluating a piece at auction or examining jewelry, you need practical applications.
You definitely do.
So let's apply this to the specific physical appraisal detailed in the research you provided. We have a set of high-grade Burmese jade pendants. Let's look at the lavender jade piece first, because the physics of that specific color are notoriously tricky.
They are very tricky. Lavender jade is highly sought after, but its appearance is heavily dependent on the surrounding light temperature.
How so?
Well, lower quality lavender jade, or stones with significant microscopic impurities, they'll look muddy or gray under warm indoor lighting. They only show their purple hue under cool natural sunlight.
Oh, I see.
But the appraisal notes this specific pendant is remarkably clear and vibrant regardless of the light source.
Which tells us that the crystalline structure is immaculate. There are no competing trace minerals absorbing the light and deadening that color shift.
Exactly. It's incredibly pure.
Next is the imperial, or apple green piece. The documentation highlights its icy or watery translucency.
That icy quality is a direct optical result of the extreme density we discussed earlier. When the granular structure is that tightly packed, light penetrates deeply into the stone without being immediately scattered by internal microscopic fractures or porous gaps.
So it's not bouncing off imperfections.
Right, you can literally look into the depth of the stone. Coupled with a vitreous glass-like luster on the surface, it physically looks like frozen green water.
It almost makes you feel that cold texture just by looking at it.
It really does.
And finally, there's the yellow or honey jade. Now, yellow jade gets its color from natural secondary staining, right? Often from earth elements that seeped into the stone millions of years ago.
Yes, that's correct.
But the appraisal notes its exceptionally low impurities and smooth texture. The color is perfectly even, not splotchy.
And it's important to note how these stones are actually cut, too. They utilize the cabochon cut.
Right, and in the context of jade, the cabochon cut serves a very specific optical purpose.
It's not like cutting a diamond.
No, not at all. When you fasten a diamond, you are creating tiny mirrors to force light to sparkle and flash outward. But jade is all about depth.
It's about that internal glow.
Exactly. The smooth, domed surface of a cabochon cut acts like a magnifying lens. It gathers the ambient light, pulls it down into the densely packed Kayakthar grains, and creates an internal glow. You aren't trying to make the stone sparkle, you are trying to illuminate its internal chemistry.
That's a great way to put it. And when you set those domed cuts into modern gold and silver mountings, the highly reflective metals act as a mirror at the base.
Pushing the light back up.
Exactly, pushing even more light back up through the bottom of the stone, maximizing the vibrancy of the chromium, or that natural yellow staining.
So if you are out there and you're holding a piece of jade, how do you verify you aren't holding a rusting Guatemalan time bomb accompanied by a legally deceptive lab certificate?
You really have to test the physics yourself. First, test the specific gravity.
Right.
You need to see that density hit the 3.33 mark. If it's hovering at 3.20 or 3.25, just put it down and walk away.
Don't even risk it.
Don't risk it. Second, use a 10x jeweler's loupe. Look past the surface polish and examine the internal granular structure. You are looking for the tightly locked, intertwined grains, the Kayakthar.
And if it looks loose?
If the structure looks loose, excessively granular, or porous, it lacks the Burmese pressure. And finally, test the color under varying light sources, particularly the lavender pieces, to ensure the color is intrinsic to the stone's chemistry and not an optical illusion created by the jeweler's showroom lighting.
Which brings us to the core of what this all actually means for you. We started this deep dive looking at a simple green stone, but we've uncovered a microscopic battlefield.
A literal war of elements.
Yes. Jade isn't one mineral. It's a fundamental divide between jadeite and nephrite. And even within jadeite, the geographical origin fundamentally alters the chemistry and the stability of the stone.
It changes everything.
The difference between a priceless generational heirloom and a fading imitation really comes down to the microscopic war between chromium and iron and, how tightly the earth decided to crush the stone millions of years ago.
It requires a massive shift in how we approach value. Whether you are evaluating a potential investment, examining a piece of historical art, or simply trying to understand the physical realities of the objects around us, you have to look past the surface.
You really do.
You have to understand the mechanics beneath the polish.
And as we've clearly seen today, sometimes you even have to look past the official lab certificate. But before we wrap up, we always like to leave you with a final thought to mull over, something that builds on the chemistry we've explored today.
Think about this. If a Guatemalan stone and a Burmese stone look completely identical to the naked eye while sitting under the bright, perfect lights of a jewelry store today.
Right.
But the Guatemalan stone's loose, iron-rich structure guarantees it will eventually oxidize, fade, and turn brown years from now. Is the true value of a gem found in the beauty it holds today, or in the promise of the beauty it will maintain long after we are gone?
That is a phenomenal question. Thank you for joining us on this exploration. We invite you to bring us another fascinating topic for our next deep dive. Until then, keep looking beneath